Hello, everyone. I'm just going to give, it looks like we're missing 3, so I'm just going to give them just another minute while I pull up all the things that we need today. Okay. All right. So we've got 17 out of 20. If they come, I'll just admit them as they go. So everybody did really well on our last quiz. All of your grades are online. If for some reason you can't see your grades, let me know. Those of you that want to know what you did incorrectly, for the most part, if you got a problem wrong, I wrote underneath why that is. I don't really know what that looks like on your end. Has anybody been able to see what that looks like? Has anybody checked that? Okay. Let me know if you're having trouble seeing that, and I can reach out to support and find out. But there was a little box for me to give feedback. So ostensibly, I would assume you could see that feedback. So the lecture that the worksheet, and the quiz that we had last week sort of builds on what we're going to be doing this week. So basically, I had to give you the basics about statistics so I could teach you how to write it up. So since this is a writing course, one of the things I wanted to show you guys how to do was to have the ability to take raw statistics, put them into a comprehensive table, and write it up the way a researcher would do. I have noticed that a lot of students have trouble with that. So I thought this would be a good skill to teach you guys. So what I'm going to do is I'm going to share my screen. I've got the lecture for us today. And the other thing that I have is several PDFs of published articles. So as we go through the lecture, I'm going to also share my screen with these articles. And if you're interested, I can also share those articles with you so that you can see real examples of tables and the write-up that goes along with it. And then on Wednesday and Friday, we'll be doing a worksheet. So just like last week, we're going to do sort of a Zoom lecture. We will do the problems one at a time, and I'll be able to give feedback in real time. So the lecture that we have today is split into part 1 and part 2. Both of them are very short. Part 1 just shows you how to set up a table. And I'm going to give you the couple of examples I'm going to give you is a t-test table, which is often the way that you show your descriptive variables, which is like how many males, how many females, how many minorities, Caucasians, so on and so forth. And then the other table I'm going to show you is a correlation matrix. And then the second part of the lecture is how you would actually write up a results section. So I'm going to give you the basics about how you structure your hypotheses, what goes in a results section, and then how you write about it with the corresponding tables. And then again, I've got some PDFs of published articles that I'm going to show you specific examples. And then on Wednesday, we're going to practice taking the raw data from the printout that I showed you from the statistical analyses that I did from our shoot, don't shoot drill. I'm going to show you how to take that raw data and put it into a nice, pretty table. And then on Friday, we are going to take those tables and we're going to work on how you write it up properly with EnglishWorks. Questions about that before we begin? Okay. So let's start with the lecture. So let me actually just,
Dr. Hill, I have a question about the quiz.
yes.
So when I went into my grades to view the quiz and stuff, it just showed me the grade and it didn't give me a place to find like comments or anything like that.
Really? Okay. Let me ask, I have like a contact in the support, like the online learning support. Let me ask her how you access that. Because I definitely gave you feedback. So I honestly, I have no idea, because I just see the teacher view. Does anybody know how this works? Has anybody been able to see feedback from me?
I haven't been able to. I don't know
Okay.
now.
All right, let me email that woman after class and find out how you see that. Thank you for letting me know because I have no idea. So stay tuned for that answer. Okay, so I assume everybody can see the lecture right here. We got it? Okay, so part one, we're going to talk about how to create the tables. So just a quick review about the variables. This is always very important for when you're creating tables. The variables are what we're putting in the table. So the independent variable is, again, what we are expecting to influence our dependent variable. So in the simplest terms, usually your independent variable is whatever treatment that you're doing. So a lot of the times when I do the dog training program research, being a participant in a dog training program is my independent variable. So what I'm expecting to influence my outcome. So your independent variable is what is the test, the thing that we're expecting to change some other behavior. And your dependent variable, we often refer to that as your outcome variable, and we are expecting that variable to change based on that independent variable. The other variable that is important to know is what we refer to as a control variable. Sometimes researchers refer to these as covariates. It's the same thing. Basically, what a control variable is a series of other independent variables. So other variables that we think might affect that dependent variable. So if we're taking our example of a dog training program, so in this instance, what I often do is the effect of participating in a dog training program, which is my independent variable, on recidivism upon release. So committing another crime, right? That's my dependent variable, my outcome variable. My hypothesis is that participating in an animal program, independent variable, is going to reduce your likelihood of committing another crime, which is our dependent variable. So with those two variables, I can conduct a t-test or I can conduct a correlation. Neither a t-test nor a correlation will take into account other variables that might influence that. So things that often influence criminal behavior is age. So I might want to control for age. We know that the older you get, the less likely you are to commit a crime. So my other control variable that I want to account for might be age. I also might want to account for the number of times these people have been incarcerated before, or whether they have a substance abuse problem. So control variables are just any other variable that you think might affect that outcome variable. So in order to account for a control variable, we need to go beyond a bivariate correlation. So we need to go beyond independent and dependent, and we need to go into something that we refer to as a regression, which we're not learning about in this class. If you're interested in that, you need to take a statistics class. But the three variables that you need to understand to create tables are your independent variable, the thing that we are thinking is influencing our dependent variable, and then control variables, which are the other variables that we think might influence that dependent variable that we want to take into account. So let's talk about how you set up the table. So the first thing that you want to do is give the table a name, and you want to give it a number. So we want to call it table 1, and then usually it's the name of the statistical test and what we're testing. So for instance, we might say table 1, t-test of the experimental group and the control group. Table 2, correlation matrix among the control variables, or you might say often your table 1 is your descriptive variable. So you might say Table 1, descriptive variables from experimental and control group. So the two things that we always include first with that title is the number of the table number whatever, and then the title that we give it. Then in the next slide, I'm going to show you an example. The other things we need to do is we usually put the variables along the side and the groups along the top. So just quickly, right here we have the groups, the males and the females, and the variables along the side. And you can see right here that I've called this table 1 t-test of means for memory, score, and implicit bias. So when we set the table up, we want to title it. Usually we put those variables along the side, the groups along the top. The other thing that you always want to include in a table is your N or your sample size. There are two ways you can note your sample size. You can either put them in right here, or sometimes you see where it says note at the bottom. Sometimes you can just put your sample size down there. But somewhere in that table, you should be putting your sample size so the reader knows how many people we're talking about. So like I said, either in parentheses beside those groups or at the bottom. The last thing we usually want to note when we're setting up a table is statistical significance. So usually you denote something that's statistically significant with a star, and then at the bottom you can tell the person how statistically significant that is. So if we look right here, we can see that there is, both of these relationships are statistically significant, but the note tells us that 1 star means it was significant at 0.05, 2 stars means it was significant at 0.001. So this is more significant than that. So generally what you're doing whenever, that's why it's easy for me when I'm looking through a table to quickly see if I've got significant relationships, because I just look for those stars. So let me give you some examples. So this is a t-test sample right here. So I'm going to give you, a lot of times what researchers will do is they will give you their descriptives. So they will show you the numbers of all the variables, and they will include that with a t-test, especially if you're comparing groups. So what I'll show you quickly, let's see. So this right here is an article at, oh, I did not share the screen with you. Never mind, hold on. 1 minute. Come on, computer. Okay. All right, can we all see this table right here? So this is an article that I published about 3 years ago. So what I did was I gave you all the descriptives of all the variables, and I also did that at the same time as a t-test. So what I've got here is I've got the name of my table. I've got table 1, descriptive statistics for dependent variables and covariates. Again, covariate is just a fancy way to say control variables. Spectre was my treatment group. This was a group of inmates that participated in a work program in a prison. So I had 1,950, and then my comparison group was 31,000. So you can see right here, I've got my groups along the top. So my Spectre and my control group, these were all my dependent variables. So I was looking at employment upon release, rearrest for 1, 2, and 3 years, rearrest for a felony, all of these dependent variables. And then here are my covariates here. And all of these stars are telling me that I have differences between the treatment group and my control group. So right down here, you can see that 1 star means that it was significant at 0.05. So right here, having a co-occurring disorder, so having a psychiatric disability as well as a substance abuse disorder. So we can see that that was significant at 0.05. And in my treatment group, we see that they were less likely to have those problems than my control group right here because the number is lower amongst them. We can also, come on computer, it's freezing a little bit. And then we can see right here that anything that's got 2 stars is even more significant than the other one. So you may notice in here, I didn't mention the word t-test, but I mention it right down here. There's just 2 ways to do a t-test, a one-tailed and a two-tailed test. You don't need to know all of that, but this is how I'm telling my readers right here that I conducted t-tests. So a lot of authors will do their descriptive variables, and if they're looking at 2 groups, they'll create the t-table or the t-test table and the descriptive variables together. So here's how we would set that table up. Let's see, what else we got? Here's another example of a t-test. We need versus. On page 255. All right, so here we have 2 t-tests as well. And you can see the name. We have table 1 in the name, table 2 in the name. We've got the test up here. We have the groups right here and the variables along the side. Same thing, you can tell if something is statistically significant based on the stars. And they tell you right here how significant it is. This T over here, whenever you do a t-test, it spits out a number. You can include that or not. Let's see. I'll show you one other table of just demographics. We'll do bias in video evidence, and that's going to be page 126. Okay, here we go. We have our descriptive statistics right here. You can see the different groups that they have. The variables along the sides, they've given you their sample sizes along the bottom. This is the mean right here, and SD is standard deviation. So you can kind of see all t-tests, all descriptive variables, all of those tables are set up very similarly, where we have the table, the name, the variables along the side, the groups along the top. All right. Questions about that before we move on to a correlation table? We good on that? Okay, let's look at a correlation matrix. So these tables look a little bit funky, but they're really not that funky when you break it down. So it always shows you, like it only fills up like half of the boxes, because what we do is we do all the variables across the top and then the same variables across the bottom. The reason, who can tell me why we have ones all the way down like this?
Because you're looking at the same you're looking at the same variable, so the differences between the variables is just going to be 1.
Exactly.
Like the correlation between the variables is going to be 1.
It's not differences, it's correlations. So
Yeah.
Age is obviously perfectly correlated with age. So remember, a correlation will spit out an R statistic that gives you a number between 0 and 1. The closer it is to 1, the more likely or the closer it is to a perfect correlation. So you can see right here, age is perfectly correlated with age. Gender is perfectly correlated with gender. Memory score, implicit bias. So if we wanted to fill the whole table out, it's not necessary, because if we wanted to see the effect or the correlation of age and gender, which would be right here, where else might we find that number?
Next to it.
Exactly. It's already over here. So this is why you only, when you're creating a correlation matrix, you only need half the table filled out. So it's always going to look like this with the ones down the sides and the actual correlations. These are statistics within. So same thing, the way we set up the table before, we have the table number and the name. We've got our sample size down here, and we've got the stars to denote how statistically significant they are. So we can see here that age is statistically related to memory score and implicit bias. Gender is only related to memory score, and memory score and implicit bias are significantly correlated. So you can see here, so we see that gender and age is not correlated, which that doesn't make sense. They shouldn't be. Those two variables don't make sense. And gender is not significantly correlated with implicit bias. All right, let's look at some real examples. So we've got correlation working. Okay, here we have just another example of our basic table right here, and then page 126. Oops, too far. Oh wait, 310, sorry. All right, so here we have a correlation matrix, and you can see again, they've just done half the table just like this. So for them, instead of writing the names out again, they've just numbered them. So age is number 1, so that you can see 1 is here. And when you're setting up a correlation matrix, you need to make sure that the same order you put these variables here, you do them across the top. So what they've done here is they've bold-faced type indicates significant correlations, and then we've got, sometimes they'll use a little cross. I don't know why. Sometimes people use little crosses, sometimes they use little stars, but generally any sort of thing out of the ordinary in that table is usually going to denote something that is significant. All right, we have that one. Let me show you one more. Correlation matrix, nurses, where's that? $255. And here we have the same thing again. So you can see again, a correlation matrix is always easy to tell because it's got half that table in there. And just like the other one, instead of writing the variables across the top, they've just numbered them so that you can see which one it is. And instead of writing ones all the way down the side, they just put like a little dash so that you know that these are the perfect correlations right here. We got it? Okay. So that's how you structure a table, the tables that we need to do. So on Wednesday, what we're going to practice is just creating creating tables from raw numbers that I'm going to give you from our shoot, don't shoot drill. And then on Friday, what we're going to do is practice how to write them up. So I'm going to walk you through all the things that a results section should include, and then I'll show you some examples as well. So the first thing to note is one of the first things that you may write when you're creating your results section, or you might have a section called the current study, and you might start with your hypotheses or your objectives or your research questions, and then you go into specifically how you did the study. So if you're going to tell the reader what your hypotheses are, this is how you denote it. So if you have 5 hypotheses, you do capital H subscore or subscript 1, and then you go through here and you're going to tell the reader exactly what this is. So your first hypothesis might be females will have higher memory scores than males. Your second one might be males will have higher implicit bias scores than females, so on and so forth. But this is how you tell your reader what your hypotheses are, is you make it just like this. So if you're gonna do this, hold on. So the way that you create that subscript is pretty simple. So on the home screen down here, hold on. So you could say subscript right down here. So that's how you tell it you want a tiny little number right there.
There's also a keyboard shortcut too.
Well, Mason, I don't know that one. This is how I do it. What's your keyboard shortcut?
It on most computers, I'm pretty sure it's Control and then the two little like V looking things that are on their sides, the greater than less than symbols. If with the less than symbol, it'll make a subscript, and with a greater than symbol, it'll make a superscript.
Do you have a Mac or a PC?
I have a Dell, so
So PC.
it might be different for Mac. That's just how we learned how to do it in chemistry.
Yeah, I
So-
think for Macs, instead of Control, I think they do Command. But I don't know.
I think so.
Yeah, so, and I don't know where that is on Google Docs. So you're on your own with that one. You can just fuck around with that font thing and you can probably find it in there. But this is how you tell we're talking about a hypothesis. Each one is denoted by an H, then a tiny number. So you do your H, your tiny number, and then a brief statement about what your hypothesis is. So let me show you how this looks in a real life study. Let me find here. So the hypothesis, where is that? Where are you? I have it all written out right here. Correlation, demographic, t-test, hypothesis. Okay, bias in video evidence. This is going to be page 126. What? Oh, here we go. Okay, so oftentimes what they'll do is they will show their hypotheses and then give you a little write-up about like in more detail about why they think, or give you a little bit more detail about each of the hypotheses. So if you're going to set your table up like this, when you have those hypotheses, and then you might have like a little brief description about what they are, when you talk about the results, you need to talk about whether your hypothesis was supported by the results or not. So if you've got hypotheses in your results section, make sure that when you're discussing the results, you're discussing it in terms of the hypotheses. Does that make sense? Okay. So that's one of the first parts that your section should have, is the hypothesis section. Then when you start getting into exactly what you write in your results section, you might want to start with your objective. So you might say something like, the objective of this study was to assess the implicit bias on memory scores among individuals of varying age and gender. Whenever you're writing up results, anytime you're talking about a sample size, this is exactly how you do it. So from this, you can tell that my entire sample had 108 people in it. So N equals is always going to be your sample. And if you want to be really specific about it, it should always be a lowercase n. Lowercase means you're talking about a sample. If you're using a capital N, you're talking about the entire population. But I'm not going to be too specific about it, but just so you know, most of us will use a lowercase n because that means our sample. So there's not 108 people in the entire world, if it was a capital N, that's kind of what that implies. Since it's a lowercase n, this means that just our sample includes 108 people. So usually you want to start by stating your objective. Then you want to give a brief overview of the method. So you might say the subjects were first given this working memory test and then given this other test. And when you're writing up your results, a lot of times you will have a lot of results and you don't have to mention every single one. Generally, you want to talk about the relationships that were statistically significant because those are the only ones that matter. So especially if you've got, like, for example, in the study that I published a couple of years ago, we had like 37 variables. I don't need to talk about every variable. I only care about the relationships that were significant. So in general, you're not going to be really writing up something that wasn't significant unless it went against your hypothesis. Then you want to bring it up. So the way that you do it, the way that you typically write it up is you'll say which table you're talking about. You'll say table 1 indicates that t-tests revealed that on average females, and you can give your sample size right here, had statistically significantly higher memory scores. Anytime you're saying something is statistically significant, you want to tell the reader how significant it is. So you're saying that they had statistically significantly higher memory scores and lower implicit bias scores. So we can see the difference in the significance and then compared to males, and we give the sample size right here. So this is how you would write it up. So we always do the sample size in parentheses and equals. Anytime we're saying something is significant, you want to tell the reader how significant it is. And if there are differences, you'll denote that significant level differences next to the variable that you're discussing. Does that make sense? We got that? Okay, so when you're writing up your sort of continued, let's talk a little bit about your correlations. So you guys did a little bit of this on your quizzes last week. But when we have your second quiz or your quiz next week, it'll be a week from today, you're going to have to be a little bit more specific. So I let a couple of things slide in the quizzes last week, but this coming week, you have to be more specific. So when you're talking about correlation, the first thing you want to do is indicate the strength and the direction. So a lot of you did this correctly. So it would look something like this. Table 2 revealed that there were statistically significant positive relationships between age and memory, and blah, blah, blah. And you see the differences in our statistical significance here. And then you want to further interpret it. So the correlation coefficient indicated that as age increases, so does memory score and implicit bias, because you're telling me it's a positive relationship, but you also need to interpret it and say in plain English what this means. And oftentimes you'll give that R coefficient right here. So that'll be the first thing that you tell me. And then when you have to calculate your coefficient of determination, so for the most part, you guys did this correctly. So to calculate that, you just square the R, and it tells you the percentage of the variance in one variable that is explained by the other. So the way that you would write this up, you would say the correlations were strong to moderate, which we can see right here. Age was responsible for about 60% of the variance, and memory scores was responsible for this percent of the variance. So to further explain that, sometimes students have trouble understanding the variance. What that means is it's saying that one variable is responsible for this much of the change in the other variable. So if it's responsible for 60%, that means that some other variable that we're not measuring is responsible for 40% more of why that variable changes around. So remember, a correlation can only account for 2 variables, so we can't control for other variables. So it's unlikely that one variable, your coefficient of determination, is going to explain the entire variable. So the last thing that you want to do is discuss your results in the context of your hypotheses. So when you have hypotheses, after you sort of talk through exactly what the numbers say, then you're going to tell me if this supported your hypothesis or not. So you'll say it sort of like, these results reveal that hypothesis 3 was incorrect, as memory score was positively correlated with age, contrary to our prediction that memory scores would decrease as age increased. On the other hand, so on and so forth. So first you want to tell me what was significant in the direction. Then you want to interpret it. Oftentimes you want to tell me about the percentage of the variance with the coefficient of determination, and then discuss it in the context of your hypothesis. So this is kind of what I'll be asking you to do on the worksheet and also to do in the quiz. So for instance, I might give you a hypothesis and a table and ask you to interpret what it means, and then also to tell me if this supports the hypothesis or not. So let me just show you a few examples. And like I said, if you guys are interested, I can put these samples up online so that you can see how published researchers have done this, and you can kind of just model how they do it. But we'll also be practicing on Friday about how to write this up. Okay, so let's do. So you can see right here, and this is the other thing that's really annoying about research. I thought it should be the other way. They always want you to describe your table and then put the table underneath. To me, I would think you would want to see the table and then write the description underneath it, but that's not how we do it. So you always want to look above the table for the description. So if we're using this, come on, if we're using this table right here, and I'm just talking about the variables, you can see right here, it says table 1 displays this, blah, blah, blah. And you can see how, you know, for example, 65% of the inmates in the treatment group were rearrested compared to 76%. So I'm just giving you some variables here. And then I can say, so remember this one, almost everything was significant. So the way I indicate that, I say as table 1 indicates, the differences were, the majority of them were statistically significant right there. So that's one. Let's see. When you're talking about a t-test, nurses, where's that one? Page 254. So you can see right here, they're giving you the their significance level. They're giving you the actual t-test score. You can see the t-test right here. They'll tell you when something is significant. For writing up a correlation, you can see right here, a strong and significant positive correlation was found between this, this, and this. Let's see. And then one more example of a correlation write-up. $310. Oops, wrong one. Right here, I think I already showed you guys this one. So things to note about this. this is what I'm going to be asking you to note, just in general. These, if you ever see this, this means the people are talking about their hypotheses. Usually in a results section, you state your objective, you give a brief overview of the methods, and then when you're talking about your findings, you really just hone in on the statistically significant ones. Always give your sample sizes. This is how you tell somebody how significant it is. And then when we're talking about correlations, these are the things that we usually need to note. The strength and the direction of the coefficient, if it's significant. And if we're going to do the coefficient of determination, this is how you write it up. Age was responsible for 60% of the variation in this and 37% of the variance in this. And then always, if you've got hypotheses, always talk about it in terms of whether the results supported or did not support your hypothesis. So on Wednesday, what we're going to be doing is talking about, we're going to be doing our worksheet on how to put things into a table. And what I'll do is pull up the shoot or don't shoot drill results. I've got some of those built into your worksheet. We're going to make all the tables look really pretty, because when you use a statistical tool like Stata, it doesn't print it, it doesn't spit it out really pretty. We need to make it into a pretty table. So we're going to practice making tables on Wednesday, and then on Friday, we're going to write up the results section from those tables. We're going to make it sound really nice. Questions? No questions. Okay, whoever, I think it was Mason, was asking about how to see your feedback. I'll email my lady and figure that out, because I have no clue, but I definitely wrote feedback in there, so stay tuned. I'll let you know how to see that. But for the most part, you guys did really well on your quizzes, so keep up the good work. If you have appointments with me, so this week, let's see, we got Jonathan today, and then on Wednesday, I'm seeing Taylor, Sarah, and Juan. So the way that works is in the morning, I just send you a Zoom invite, just email me your paper, and then we'll just do a one-on-one consultation. So for the rest of you, I'm going to be sending out emails probably this week and next week to set up a one-on-one Zoom session so that we can work on your paper. I'm also talking to my friend at the police department to see if it's possible for us to learn how to write up an arrest report and a police report via Zoom. So I'm going to talk to her this week and see if we can do that. If it's just not possible, or she is like completely overworked because she's an essential worker right now, then you guys will just get a free week. So stay tuned for that. Okay.
Dr. Hill.
Yes.
If she can't do it, my dad works in law enforcement. He's working nights this week, so he could probably do it.
Okay. I like that idea, but I'm a little hesitant to do that because I don't know your father.
Right.
I'm pretty sure she's going to be able to do it because her job is recruiting. So
Yeah.
I don't really know what they're going to have her do. But it's more of a logistics issue that I'm concerned with.
Yeah.
Less than the ability to do so. Like, I think if this works, I can send her an invite to also be a host, and then like she'll talk some, like what we discussed previously was like her showing like a YouTube video, then we'll work through a worksheet at the same time about like how you would write up the things that you would note. So it's more of a logistics issue than anything. But as a rule, I don't really have people come in to guest lecture until I know them pretty well. So nothing against your father, but I don't know him. I've had some horrible experiences in the past. One time at Florida State, I had a cop come in that I did not know, and he was using inappropriate words for minorities. So not that I'm saying your father would ever do that, but I'm just really hesitant about having someone speak to my class before I have vetted them. But thank you for the opportunity. I think it's going to work out. I think we'll be able to do this. I just have to figure out the logistics as with everything now that our world is ending. Other questions?
My meeting's scheduled for 2:00 today. Can we like
That's right.
do it now, like after everybody else gets off, or do you have to something else that you're doing?
Yeah, I have to eat. Like, this is
Okay,
my
that's
lunch
fine.
hour.
I'll
Like,
wait.
I mean, my child is he is stealing all my nutrients, and I have to re-up.
How's your
Okay,
baby
that's
doing?
fine. I don't really have anything else to do.
Why? Why do you want to do it right now? And plus, I've been lecturing for 4 hours. Like, give me a little break.
Okay,
Um,
I need to go work, and I just wanted to go earlier because the earlier I go, the earlier I can leave. So
Do you want to do 1 o'clock instead of 2 o'clock? Can we do that?
yeah, that'd be great if you could do that.
Yeah, okay, so I'm gonna edit our meeting and then I'll send you a new Zoom invite. I don't know if, yeah, I think I have to send you a new invite. I don't fucking know. I'm gonna send you a new invite. Let's do 1
Okay.
o'clock, but I need a
Okay,
little
that
break.
works.
Okay, Jonathan?
Okay, thank you.
You're welcome. Anybody else?
Dr. Hill,
Yeah.
how's your baby doing?
What?
How's your baby doing?
Oh, he's huge. Like, I can't really bend over anymore. Like, anytime I drop something on the floor, I can't get it. My husband got me this amazing pregnancy pillow, but I get stuck in it all the time. Nothing fits. This shirt, you guys don't even know, it's only half buttoned. Like, it's a whole thing. But other than that, going great. I have cankles. That's new. That started last week. What a gift. Anybody else? I'm glad you can't see the bottom half of me because, like, for real, I only have like 4 buttons. Like, the rest of it doesn't fit. The shirt doesn't fit. Nothing fucking fits. Oh, sorry, Thomas, you have a baby there. Didn't mean to be dropping F-bombs in front of your newborn.
This is your future.
Okay. Just giving him a sneak peek of how people talk. Sorry about that. Okay. Other questions?
When's your baby due?
June 25th. So I really hope the world is done ending by then and the hospitals aren't like full of COVID. So fingers crossed.
One of my close friends, her baby's due in 3 days.
Yeah, no, I mean, I'm thankful I've got like another 2.5 months. Like, I'm hoping our hospitals can get figured out before then because that just seems like a
I
whole
say
thing.
baby, but it's actually twins. She's having twins on Thursday. So
Oh
yeah.
my God. How does she know it's happening on Thursday?
Because
Being
they're
induced?
doing a C-section
Oh,
because they're too big. Like they're getting too big.
oh man, that sounds like a nightmare. Oh man. Other questions? Okay, so I'll see you guys on Wednesday. Don't forget to download. So starting at 10:45 in the morning, you can download the worksheet, and then we're going to go through them one at a time, making everything look all pretty in tables, okay? All right, Jonathan, I'll see you at 1. If anybody else wants to do a one-on-one meeting, shoot me an email. My office hours are until 3 o'clock today, okay? See you guys later.
Thank you.
Bye, guys.